For understanding the circle theorems, first we need to understand few words about the circle. Okay. Let's say if this is a circle, of course you are all aware about the center of the circle. Center is the point. If you will take the distance from the circle, the distance from the center to the circle, we call it radius. This is radius of the circle. The outer boundary of the circle, we call it circumference. The outer boundary of the circle is called circumference. Okay. Now, if inside a circle you cut any part, just like if you will cut any part from the circle, from the center, make sure, like this one is, for example, if the center is O, this is A, this is B. If you cut any piece from the circle, like OAB, we call that as, that will be sector. Okay. For example, just like you cut a pizza from the center, one piece of the pizza is called the sector. Now, right now, for example, if I look at this one, you can see there are two sectors. One is this smaller sector, OAB, that is this one, and the other is this larger sector, this one, starting from here, moving to this side, this larger sector. Okay. Now, this is, if you take a part of the circle, so this one, A to B, we call it, it is an arc. This AB is an arc and we write it in this way. I will read it arc AB. But if we join the 2 points on the circle, just like if I draw it a straight line, like there are any 2 points on the circle, so we join them, the line that joins them, we call it, this one is a chord. But I will say it is a chord. For example, if I'm taking this circle, let's say this is a circle. Okay. And you take the 2 points on the circle. This is A, this is B. So from A to B, this is arc AB. But if you join them with a straight line, the straight line AB, we call it the chord of the circle. In the same way, like let's say if you have this circle, if this is a point, this is a point, you join the 2 points of the circle, the line that join that any 2 points of the circle, we call it the chord of the circle. Like in this case, this is a chord of circle. If the chord passes through the center of the circle, like let's say if this is the center of the circle, if the chord passes through the center of the circle, such chord we say is the diameter of the circle. It means diameter is also a chord, but it is considered the longest chord of the circle. Okay. The diameter divides the circle into 2 equal parts, like this part and this part will be equal. We call each part as a semicircle. All right. Once again, a radius is the length of the line from the center to any point of the circle. If a circle have many radius, like let's say, the plural word of the radius is radii. The plural word of the radius is radii. Like let's say, if this is a circle and it has many radius, so starting from the center, this is radius, this is radius, let's say this is R1, R2, this is radius. From center to any point of the circle, the distance is called radius. If a circle has many radii, remember all radii will be same, will be equal. In R1, R2, R3, they will all be equal if they are the radii of the same circle. So they will be equal. Okay. So these some vocabulary words, circumference, because this will be the most used word in the circle theorems. Circumference of the circle. So this outer boundary, this is the circumference of circle. We call it the circumference of the circle. Okay. Now let's move now toward the circle theorems. In circle theorems, let's say I'm going to take a circle. If this is a circle, let's suppose this is the center of the circle. O is the center of the circle. Let's say I'm taking any chord AB. If this is a chord AB, or even if you take the arc AB. Now this chord is making, if we join it, let's suppose this chord make an angle at the center. Okay. This one, let's say, is theta 1. This symbol, remember, we read it as theta. So let's say the center is theta 1. What I will say this is angle by chord. What is theta 1? Theta 1 is the angle by the chord AB at center. I mean, this is the chord. So from take this chord to the center, the angle made, that I will say is the angle by the chord AB at the center. Now, if the same chord, let's say, if from this chord I take it anywhere on the circle, from here till here, let's say this angle is theta 2. So what I will say, theta 2 is angle by chord AB, because look again, same chord AB is making the angle on circumference. Okay. Now you should understand these meaning. If I say angle by a chord at the center, so you should understand what it means. Okay. Now if I say the angle by the chord on the circumference, you should understand that. In the same way, let's say I'm going to say this one. This is again chord AB is making this angle. So what is that one? What should I say? It is same. I will say theta 3 is also angle by the chord AB on the circumference. Mean chord AB is making angle at the center, chord AB is making an angle at the circumference, chord AB is making another angle at the circumference. Like theta 2, theta 3 are on the circumference, theta 1 is at the center. Okay. So the first rule is rule number 1 that we say. That rule is angle at the center of circle is double than angle at the center of circle by a chord. Sorry, I should write it. Angle at the center of circle by a chord is double than the angle by same chord at circumference. This is the first circle theorem. What it means? Look, theta 1 is the angle at the center by AB. Theta 2 and theta 3 are the angle at the circumference by the same chord. So I can say theta 1 will be 2 times of theta 2, or I can say theta 1 will be 2 times of theta 3, because both theta 2 and theta 3 they are made by the chord AB. So if the same chord make an angle at the center and the same chord make an angle at the circumference, their angle will be double, or in other words, this angle will be half of this angle. Okay, let me give you one example. I'm going to take a circle here. If let's say this is a circle, and in this circle, I'm going to say I'm going to take this is a chord AB. Let's say this is center O. Now, if I will say take this one, join this line, it will make the chord AB. Yes. Let's say this angle is 30 degrees. And now if the same chord make an angle here, let's say this one is C. And let's say the same chord make another angle here. Mean they are joining. Let's say this is D. So look, what is angle AOB? Angle AOB is 30 degrees. Yes. Remember this symbol, if you write, we read it as an angle. This is angle AOB. Angle AOB is 30 degrees. Okay. Now, what is AOB? AOB is at the center by AB. By the chord AB, it is at the center. So if I take ACB, ACB is on the circumference by the same chord. So what its value should be? At the center is always double than at the circumference. It means this angle will be 15 degrees. Okay, it will be 15 degrees. In the same way, this is by the chord AB. Yes, AB is also making on the circumference this angle. So this should also be half than the angle at the center, because they are, look, ACB and ACD, these both angle are by the same chord AB. Okay, so they will be if this is, so they will always be half than the angle at the center. So this will also be 15. This is the meaning of the first rule. That angle at the center of a circle by a chord is double than the angle by same chord. Because remember this one, by same chord. Any other chord might be different. So by the same chord, if you have an angle at the center, the same chord make angle at the circumference, what will happen at the center will be double than at the circumference. Okay, is this first rule clear? So whenever you see any question of the circle theorem, because there are 7 to 8 rules, you have to start with the first one. Always start checking with the first one, so you will never find the questions of the circle theorem difficult. Okay. Is this clear, please? If it is clear, then I'm moving to the rule number 2. The second rule for the circle theorem. Let's say we have a circle. Let's say the center of the circle is O. Okay, let's say there is a chord AB. Let's say this is a chord AB. Okay, I'm going to make chord AB is making an angle here. Chord AB is making an angle here at point C. Okay, let's say the same chord makes an angle here. This is D. Let's say the same chord AB makes another angle, this one, on the same side. Okay, let's say this is E. This chord is making. So you can see there are 3 angles made by AB on the circumference. What it make? It make angle ACB. It make angle ADB. It make an angle AEB. Okay, they are on the same side. When we make a circle, one more thing that you have to keep in mind. When we make a circle and take a chord, the chord make the 2 segment of the circle. This is one segment, we call it the larger segment, or we call it major segment. What we call it? Major segment. Okay, this is the other one. We call it the minor segment. This one is a major segment and this one is a minor segment. So the second rule says that if one chord is making many angle on in the same segment, they will be equal. Angle by a chord in same segment are equal. For example, look, ACB, ADB, AEE, they are all in the same segment because look, when we took the chord AB, this was the minor segment, this was the major segment. So all these angles are in the same segment by the same chord. So it means they will be same. Whatever its value, they will all be same. Okay. So I can say, according to this picture, I can say, for example, if this is 10, this will be 10, this will be 10, because they are by the same chord. They are by the same chord, so they will be equal. Now, if I ask you a question from here, this is at the center by the same chord, then what this angle will be? If these are 10, 10, 10, what this angle at the center will be? Remember the first rule. Same chord that will make at the center will be double than the circumference angle by the same chord. So if these are 10, 10, 10, so what this will be? 20. Okay. So this is the second rule. The first rule tells the relation between the angle at the circumference and center. The second rule tells the relation between all the angles at the circumference by the same chord. Okay. But they should be in the same segment, provided the condition is they should be in the same segment. Okay. Clear? Please let me know. So I will move to the rule number 3. And these two rules will be the most used rule. There are 7 to 8 rules, but these two rules are the most used rules. Means in almost every single question, every second question, you will see, or in every question at least you will use it. Okay. Clear?
Yes, sir.
Okay. Now, coming to the rule number 3. Rule number 3 is, if you remember the vocabulary words that we are using, then will not be problematic at all. But before that, let's understand another vocabulary word. Let's say I'm going to take a circle. There is a word called quadrilateral. Quadrilateral. Quadrilateral means four-sided shape. Quadrilateral means four-sided shape. Okay, let's say you have a circle. Let's say you have a circle, and on the circle there are 4 points. If you will join the 4 points, obviously it will make a quadrilateral like this: A, B, C, D. Such a quadrilateral whose all 4 points are on the circle, we call it cyclic quadrilateral. Because look, A is on the circumference, B is on the circumference, C is on the circumference, D is on the circumference. All 4 points are on the circle, we call it cyclic quadrilateral. Let's say if I'm going to make another quadrilateral here. This is O, A, B, C. Can I say it's cyclic? This is not a cyclic because look, A, B, C are on the circumference, but O is not on the circumference. If O is not on the circumference, any one point is not on the circumference, it means it is not cyclic. A, B, C, D is cyclic, but O, A, B, C is not cyclic. Okay. Now, rule number 3 says in a cyclic quadrilateral, opposite angles make 180 degrees. For example, if this is angle A, this is angle C. Okay, let's say this is A, this is C. Okay, this is angle B, this is angle D. Now A and C are opposite. So according to this rule, A plus C must make 180. In the same way, B and D are opposite. So B plus D must be 180 degrees. Because the quadrilateral is the cyclic quadrilateral. So for cyclic quadrilateral, the opposite will always make 180 degrees. Okay? Got it? Clear? Clear, please. Let me give you one example. How we will do the question related to the cyclic quadrilateral. Let's say if I have a circle here and I'm going to make a quadrilateral. Let's say this is a quadrilateral. And all the 4 points are on the circle. So I will say this is a cyclic quadrilateral. This is A, B, C, D. Okay. Let's say if this angle is 90 degrees, what this angle should be? Because opposite should be 180. So in 90, what I should add? So it will make 180. I should add 90. Okay, let's say if this is 100, what this should be? In 100, what we should add? So we get 180. We should must add 80 here. Okay. So I will say, all right. So that is the meaning of the cyclic quadrilateral. In cyclic quadrilateral, the opposite angles will make 180 degrees. That is the third rule of the circle theorem. Okay. Clear? Yes, please. Let me know. Is it clear?
Yes, sir.
Okay. Let's move to the rule number 4 now. The rule number 4 of the circle theorem. I'm trying to bring them in that order that usually, like number 1 is the most used one, number 2 is a little bit less used, and so on accordingly. Okay. Then the next one is, let's say if we have a circle. In the circle, we know that the line that passes through the center, for example, if this is passing through the center, we call it diameter. So the rule number 4 says that if diameter is also called, if the diameter, for example, this is the diameter, angle by the diameter on the circumference. Like what is ACB? I will say angle ACB is the angle of the chord AB on the circumference. And what is AB? AB is diameter. So remember the angle in the same way, I can say even take this one. I can take this one also. This is, for example, this ADB, this angle ADB is also the angle by the diameter. So remember, angle by diameter on circumference is 90 degree. Always this angle will be 90. If diameter make an angle on the circumference, it will be 90. It means this is 90 degree, this is 90 degree. Even if, for example, the diameter is making this angle, let's say this is also the angle by the diameter. So what this value will be? This value will also be 90 degree. So angle by the diameter is always 90 degree. Clear? This is rule number 4. Okay, rule for understanding rule number 5, there is another vocabulary word that you have to remember. Let's say if I have a circle, and let's say I'm going to take any card here. Okay, if this card, for example, let's see, now this card is crossing at 2 points. Yes. If I will bring it here, it just touch the circle at 1 point. Such a line that touch the circle at 1 point only, we call it tangent to the circle. The line that touch the circle at just 1 point, we call it tangent to the circle. Now, the rule number 5 says that if you have center, okay, if say this is A, what is OA? OA, I will say, is the radius. Okay, so rule number 5 says angle between tangent and radius of circle is 90 degree. Like OA is radius, this is tangent, so this angle will be 90 degree. This angle will be 90 degree. The angle between tangent and radius is always 90 degree. Same way, if you say the diameter in place of radius can be the diameter also, because the half of the diameter, remember, diameter is double of the radius. So either radius or diameter, you say. Angle between tangent and radius is always 90 degree. This angle will be 90 degree. This is 90 degree. This is rule number 5. Okay. Clear? Now next, rule number 6. Let me open the new page for rule number 6. Because once you know all the rules, solving the question will not be difficult at all. But try to make sure you use them in an order. Means you check this rule is applicable. If not, then move to the next rule. If that is not applicable, then move to the next rule, and so on. Okay, let's say I'm going to take a card. Let's say there is a card. Suppose this is card AB. And we take a tangent also. Let's say I draw a tangent and draw the tangent in such a way that it touches one of the point of the card. Okay. Now, this angle, let's say this angle is A. The angle between the chord. This chord, remember, is not diameter. Okay. This A is the angle between chord and tangent. Okay, let's say the same chord make an angle on the circumference also. The same chord make an angle on the circumference. The angle between chord and tangent is equal to the opposite angle by the same chord on the circumference. I mean, if this is A, so this will also be A. They will both be same. We call it, actually, this is called alternate segment theorem. What is the alternate segment theorem? The alternate segment theorem, this is the rule number 6. It says that the angle between the chord, the angle between, for between I'm using this short word, okay? Angle between the chord and the tangent is equal to the opposite angle on circumference by same chord. Okay, for example, let's see, the same chord can make an angle here as well. The same chord can make an angle here as well, like this angle. If this is B, so A and B will not be equal. Why? Because the theorem says that this is the chord and this is the tangent. Yes, this is tangent and this is chord. Angle between chord and tangent is equal to angle by the same chord in the opposite. Okay, mean it should be in the opposite side. So that will be this one and this one will be equal. If for example you consider this angle, now this is the angle by the chord. Okay, if for example this is, let's say, is D, so this is also D. Why? Because look, this chord, this same chord, this is the angle between this chord and tangent, and the same chord is making an angle on the circumference, this one. So these will be equal. This theorem is called, we call it alternate segment theorem. This theorem we say is the alternate segment theorem. Okay, that is our rule number 6. Rule number 7, the 7th circle theorem. Let's say if I take a circle, let's say if I take a circle and there is a point outside the circle. Let's say this is a point A outside the circle. Remember, if from this point I make a line, I want to draw a tangent from this point. And in the same way, from this point I can draw the two tangents to the circle. From a point outside the circle, we can draw maximum two tangents. Okay, let's say if this is B, this is C. So what is AB? AB is tangent, AC is also tangent. So if I draw the two tangents from a point outside the circle, then this distance AB and this distance AC will be equal. Okay. So what we will say? We will say the tangent to circle from a point outside the circle are equal. For example, in this picture, what will happen? I can say AB will be equal to AC. And one more thing, for example, if you have this center, let's say this is center. So obviously this OC and OB will also be equal. Why OC and OB will be equal? Because they are the radius. OC is the radius, OB is the radius, so they will also be equal. Then in that case, also you know what this angle will be. This angle will be 90 degree. This angle will be 90 degree. Why? Because angle between radius and tangent. Rule number 5, remember, angle between radius and tangent, they are equal. So if this angle is 90 degree, this angle is 90 degree. So one more thing, keep in mind, if you join this line, so this triangle will become a right angle triangle. Okay, if it become a right angle triangle, so remember, whatever this angle will be, this angle will be same. Mean this line from the center, if you join, so it will bisect it, it will divide it into two equal parts. And question related to this one you will see in so many exams questions. So these are the 7 circle theorems. Believe me, if you remember these 7 circle theorems and you know how to use them, solving the questions of the circle theorem will not be difficult at all. You just have to recall them. Okay. So this video I will upload. Okay. I would just request you, please watch this video multiple times, at least till tomorrow. I want you to watch it 2-3 times.